Welcome to our tutorial. Our company has been making power supplies and measurement equipment for more than 60 years. This tutorial is based on training content for new employees and is ideal for students and new members of electric companies. For our first edition, we'll go over the basics of electricity types, AC and DC. We plan to release more tutorials in the future of increasingly complex subjects. Let's get started. AC and DC simply indicate how electricity flows. DC stands for direct current. The direction of electricity does not change and flows in one direction. AC stands for alternating current. AC flows while the direction, voltage, and current of electricity alternate between positive and negative. The first thing that comes to mind when you hear DC is a battery. Battery power is output in DC. It looks like this when expressed on a graph. You can see that electricity is flowing only in one direction. The first thing that comes to mind when you hear AC is an outlet. As you all know, household power is supplied by AC. It looks like this when expressed on a graph. You can see that the direction of electricity is changing. So where is DC actually used? The insides of TVs, game consoles, and PCs all run on DC. Most home appliances actually run on DC. Furthermore, the control circuit of the car are all driven by DC. On the other hand, where is AC actually used? Electricity generated from power plants is delivered to homes through power lines, and AC is used in the process. It is also used in power lines for airplanes and ships. So, you might be thinking, which is better? Why not just choose one? In fact, two famous inventors, Edison and Tesla, battled this question out. Edison for DC and Tesla for AC in what became known as the current war. DC has the disadvantages of being difficult to transform and transmit, whereas AC transforms and transmits well. In the end, AC won the battle and became the standard type of electricity for power transmission. DC is not used for power transmission but is used in products that require precise control. In conclusion, the difference between DC and AC is whether there is a change in the direction of electricity flow. DC has the advantage of being easy to control, but has the disadvantage of being difficult to transform. AC is easy to transform, but it has the disadvantage that stable control is difficult. Each has its advantages and disadvantages, therefore the situations in which they are used differ according to their characteristics. That's it for today. I hope this tutorial has been helpful. We want to share our knowledge and hope it can contribute to your understanding for your future.